Okay, so in this video we are going to determine the empirical and molecular formula with mass percent. Uh, Basically it's the reverse process of what we've done in the previous video. In the previous video we had the molecular formula or the empirical formula, and we got the percent by mass from that, which was simple, but this is a reverse process, but it's more complicated. So how do we find the empirical formula? And we have to find the empirical formula first, and we're going to talk about the molecular formula later. So the first step is to assume that you have 100 grams of the substance. So we have percent by mass, right? For example, if you have an element, a compound like AB2, for example, if you have 20% A and 80% is B, so if we have 100 grams of AB2, we know that 20 grams of that is A because it's mass percent, right? So we assume we have 100 grams of the substance, then we can treat all the percentage as the gram of each element. Then we have to convert these grams to moles. And why do we do that? So we are trying to find the empirical formula, right? We are trying to find how many of each element is in the compound. And when we say how many, it's counting, okay? And for counting, mole is a counting unit. You cannot compare it with grams, with mass, because each element might have different mass. But if you compare them with moles, you can compare how many of this and how many of the other one, so you can find out how many of each element is in one molecule, okay? So for the second step, we convert the gram to mole of each element. Then we divide each element by the smallest number that you get, okay? And you do that because for the empirical formula, you need the smallest whole number ratio, okay? So we need a whole number. So the number you get from converting mass to mole might be something 0.23, like some decimal places. But we need a whole number. So when you divide by the smallest number, you eventually get a whole number. The last step is, in case you don't get a whole number, sometimes you end up with something like, for example, 1.5 after you divide by the smallest. But as we said, you want whole numbers, right? So you have to multiply all of the elements by a same number. In this case, for example, if it's 1.5, if you multiply that by 2, you get 3, right? And you do that with all the elements. And we're going to have some example like that, so we know what to do, okay? Okay, let's do this example. So we have a compound, we want the empirical formula, and we have the percent by mass of the elements, which is carbon, hydrogen, and oxygen, okay? So we are going to apply those 4 steps to find the empirical formula. The first one is to assume we have 100 grams of the compound. So if you have 100 grams, all of these percentage becomes the gram of each element, right? So if you have 100 grams of the compound, we have, for carbon, we have 63.15 gram carbon, and for hydrogen, we have 5.30 gram of hydrogen, and for oxygen, we have 31.55 gram of oxygen. Okay, the next step is to convert gram to mole, because we want to find out how many of each element do we have, and to find how many, as we said, mole is a counting unit, okay? It tells you how many of each element you have. So you have to convert each of them to mole, okay? So the gram to mole, I don't want the gram of carbon, I want to get rid of that. I want the mole of carbon. And if you check the periodic table, you know that 12.11 gram is 1 mole carbon. So that is 5.26 mole. And you do the same thing for hydrogen and oxygen. So when you do the same thing for hydrogen and oxygen, you have these numbers for the moles of this carbon, of all of these elements. So the next step is to divide by the smallest. And why do we do that? Because, as we said, the empirical formula is the whole number, simplest ratio of the whole number. So we cannot write like this, like carbon 5.26, hydrogen 5.26, and oxygen 1.97. We cannot write that, right? So this is not right. So in order to get the empirical formula, we need a whole number. So that's why we divide by the smallest number, which is 1.97. And we have to divide all of them by the same number. Okay, you find the smallest one and you divide all of them by the smallest one, by the same number. So this will be 2.67. This is the same number, so it's 2.67, and this is 1, right? So this is where we go to the last step, step 4, okay? So if you don't get a whole number when you're dividing them, you need to multiply by a common factor until you get a whole number, okay? If you have whole number here, you can stop and get your empirical formula. So in this one, what number should we multiply? We have to try. So start with 2. Okay, what do we get with 2? So if you multiply that with 2, you get 5.34, right? Which is not a whole number. So try 3. So I'll multiply this by 3, and I get 8.01, which is almost 1. If you get very close to a whole number, like you have 0.01, or you have, for example, 7.9897, you can take the whole number, okay? That's for maybe a little bit error in the calculation or whatever. It's okay, you can take the whole number. So if 3 works, then you do 3 for all of them. So this is the same number, so it's 8, and you multiply this by 3, which is 3. So you have 3, 8, 8 whole numbers. So the empirical formula will be C8, H8, and O3. So that's the empirical formula. So how do we determine the molecular formula? In order to find the molecular formula, first of all, you have to know the empirical formula. Then you have to know the molecular mass of the compound, okay? So if you know the molecular mass of compound, you can find the molecular mass of your empirical formula, and you can divide them so that you find out how many of that empirical formula is your molecular formula. Because if you remember, molecular formula is the simplified whole number ratio of the molecular formula, okay? It could be twice as empirical formula. The molecular formula could be twice as empirical formula, or it could be 3 times more than empirical formula. What do I mean that? For example, if you go buy cucumber, and you buy 4 pounds of cucumber, and you know that each cucumber is, for example, 1 pound. That will be a huge cucumber though. But anyway, if you have a 1 pound cucumber, you know that you have 4 cucumber in that, right? So that's the same thing. So your empirical formula is the simplest whole number ratio of that compound, okay? So if you know the mass of your molecular formula, you can divide that by the mass of your empirical formula, and you can find how many of the empirical formula is in your molecular formula. So let's have an example to understand what I'm talking about. So in this example, we have fructose, which is made up of 3 elements, carbon, hydrogen, and oxygen, okay? So let's find the empirical formula first. The question is asking about the molecular formula. However, in order to find a molecular formula, we have to get the empirical formula first, okay? So let's find the empirical formula. So we assume we can just do the 4 steps as we talked in the first slide. So the first step, assume that you have 100 gram, then you can get all of these percentage, change it into the gram of each element. So if you have 100 gram of fructose, 40 gram of that would be carbon, and 6.71 gram of that would be hydrogen, and oxygen will be 53.3%, oh, not percent, gram oxygen. Okay, so the next step is to convert all of them from gram to mole. So 12.11 gram carbon is 1 mole of carbon, 1.008 gram of hydrogen is 1 mole of hydrogen. So we have all of them in moles now. Now it tells us how many from each of these elements we have. So the next step is to divide them by the smallest number. We have 3.3, 3.33, so that's the smallest one. We divide all of them by the same number. Okay, so this is 1, this is 2, it's not a good 2, and this is 1. Okay, so the empirical formula is CH2O. Okay, that's the empirical formula. So let's write empirical formula. Okay, in order to find the molecular formula, we have to find the molecular weight of the empirical formula and see what is the molecular weight of the actual compound, which is 180. Okay, then divide that by the unit mass of the empirical and see how many of the empirical is the actual molecule. Okay, so we have to find the molecular weight of empirical. We have 1 carbon plus we have 2 hydrogens, so 2 times 1.008 plus we have 1 oxygen, 15.999, and that is equal 30.026 gram per mole, because that's the molecular weight, right? So in order to find the molecular, we know the actual molecular weight is 180 gram per mole, or you can do it in AMU. Then this is in AMU, this should be in AMU. The number will be the same, the unit should match. Okay, there's no difference. So you divide it by the molecular weight of your empirical, and you see you have almost 6 of that. It should be a whole number. Okay, this number should be a whole number. It might be, I don't know, maybe 5.998, I don't know, it should be something like that, but it's almost 6. Okay, it's something, it should be a whole number. If it's very close to a whole number, you round it. Okay, so you have 6 times of the empirical, therefore your molecular formula is C6H12O6. So that's how you find the molecular formula of if you have mass percent. First, you have to find the empirical formula. To find the empirical formula, you have to follow those 4 steps. And when you have the empirical formula, you find the molecular weight of that, and you have to know the actual molecular weight, and then you can divide those two and find the molecular formula.